And I want to show you like real quick, just remind you all what life is like without something like Terraform, right? You would probably go into your AWS console. And if I asked you to create an AWS instance, like an EC2 instance, you'd probably go into here, you'd click launch instance, you'd give it a name, you'd pick an AMI, you'd scroll down, give it a key pair, put it in a security group, yada, 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 yada. You'd click launch instance and you'd go from there, right? And now you have an instance coming up. If I asked you to do this maybe 5 times, 10 times, 100 times, would you be able to do that? Would you be able to do that cleanly? Would you be able to do that repeatably without errors? Probably not, right? So that's where Terraform comes into play. It allows you to codify that whole point and click approach into a configuration that Terraform can then read and declaratively make your infrastructure for you. So let's say you have a Terraform configuration here that creates an instance, and we're not going to be going too deep on like the configuration itself. I'm going to keep the instance very, very clean, very small, just to show you the differences that I wanted to cover. So here we have an AWS instance resource. You don't have to worry too much about what's going on at the top. This is just telling Terraform that I want to use the AWS provider. This is configuring the provider to use the US East 1 region. My actual credentials are read from my AWS CLI SDK. And then this resource block is just telling Terraform, hey, I'd like you to create one EC2 instance with this AMI and this instance type, okay? So this is how you would create an instance. You would create this configuration, save it. You would do Terraform init to initialize this configuration down to your providers, and then you'd probably do either Terraform plan or Terraform apply, right? And this is actually called, we call this like the core Terraform workflow. You write your configuration, you plan your configuration, and then you apply your configuration. And like these enable these tight feedback loops for you, right? You would write configuration, plan it to see what it's going to do. If you don't like that, write again, plan, write, plan, and you keep these tight loops. And you eventually get to the point where you have a plan that you're happy with and you can move forward, right? So here, I told Terraform to plan this, and it says it's going to create one instance resource for me with this AMI, this size, and everything else is going to be known after it applies this configuration. So I like this. I'm going to go forward, and I'm going to tell Terraform to apply this. I'll hit yes. Oh, I mistyped yes. Why yes? There we go. And now Terraform is going out, reaching out to AWS, saying, "Hey, is there an instance with this stuff already existing?" No, there's not. It's going to create it for me. If I go to my EC2 console and hit refresh, you'll see that there's an instance now there, right? If I asked you to create now, even with Terraform, if I asked you to create multiple instances using the same configuration, well, a very trivial, naive approach would be to go into your configuration, copy this whole block, and paste another one. However, this presents an issue in that every resource that Terraform manages has to be uniquely named with the type of resource that it is and its name, its identifier, right? So if I were to just copy and paste this resource block and I would say to Terraform, like, to apply this, Terraform is immediately going to say, hey, I can't do that because you have duplicate resources going on here. So I'd have to go into this and I'd have to give this a different name, like app2. And then you can see how this can become a problem, right? I'd have to go app3, et cetera, et cetera, et cetera, right? And now if I were to plan this and apply it, Terraform will say, great, I know what to do. I'll create you 2 more instances. So I'm just gonna let that happen right now. And I probably should have gave each of their tags unique tags because they're all gonna be called app, but it's fine. So that's like a more naive approach of how you would start scaling up infrastructure, the copy and paste method, right? Now I have 3 apps running. Cool. The problem with this is it becomes pretty unwieldy pretty fast, right? It's not dry, and dry is a term that is very overloaded in the industry, and everyone I think personally that a lot of people try to be dry too quickly and they shoot themselves in the foot later on. It's important to be dry when the situation calls for it. in this case, if my goal is to create identical resources, this is not a good approach because I'm not being dry in this case. If each of these three different resources were completely different, maybe an app, a DB, and like a cache or something, then yes, it would be good to copy paste and have them completely separate, right? And we'll get into that a little bit in a sec. So I have these three resources. It's not very intuitive of how I would manage them going forward, and it's very error prone. So how can we kind of like reduce this? So let me just comment these out to simulate destroying them, tell Terraform to destroy them, and let them go down. And AWS is pretty quick, so it should destroy rather quickly. And if it doesn't, I can always open up another terminal and edit the configuration while that's happening. Yeah, okay. Make that a little bigger. Okay. So as that's destroying in my other terminal, I'm letting that go away so I can move on to the next topic. What's the better way of doing this? So instead of actually copying, pasting your resource blocks all over the place, there is this argument called count. So every resource has a meta argument called count, and you can set it equal to the number of resources that you want created. Now, the advantages here are kind of twofold. One, I no longer am constrained by having different identifiers here for my resource, because the way count works, and I'll go to this content here to show you, the way count works, I'm gonna scroll down a little bit, is that it zero indexes each resource that it creates. It's kind of like a stack. Well, it's kind of like an array, but with the LIFO property. So I like to call it a stack. Every time you create a resource with count, if count is 1, that means you're getting an array of resources with one element, right? So to demonstrate that, I'm going to change this to count 1, and then I'm going to go back to apply this, and you'll see that it wants to create one resource. So scroll up for a little bit, named AWS instance app 0, right? An array of one element essentially is what's happening here. If I scale count up and down, my array of resources essentially stretches, but it does so in the last in, first out principle, right? LIFO. So if you'll see here, if I were now to modify this, change count to 3. So I'll do that real quick and then reapply. Cool. Now I'm going to get AWS instance 0, 1, and 2, right? So this is great. I can change that count to as high as I want. Life is good. But what happens when I want to create maybe an n number of infrastructure, but I care about like which one is which, right? So a lot of people, let's say I had the use case to provide maybe, I don't know, a developer instance, like an app instance in a dev environment to each of my developers, right? In this case, I'm saying give me 3 of them. But so I have 3 developers. What happens if I want this count to be more, I don't know, dynamic, right? Well, a very interesting approach that you can do is you can have count based off of a variable. So let's say I had a list of my developers, right? And I'm just gonna copy this, it's not worth typing out. There you go, cool. Let's say I had a list of the developers that I wanted to create an instance for. I can have this beautiful list here, and then I could update my count to just use this length of that variable, right? So if I added people to that variable, my count would grow and I'd get more resources. If I took people away, my count would decrease. So let's see that approach. This is a common approach that people tend to turn to when they want count to be a little bit more dynamic, but it has its own drawbacks as well, right? So I have Alice, Bob, and Charlie. They are my developers. I can now give them all instances. And when I'm using this count meta argument, I get access to these special variables called count index. So now I can actually name these instances using the index. So count index +1. The +1 is there because arrays are 0 index, and I want them to be indexed by 1. And then maybe I'll give them an owner tag, and this will just be like, you know, var.devs, and then whatever index that we found that dev in. Cool. And I don't need these quotes, so I'm going to remove them. Cool. So I'm just going to update this configuration. And now you'll see Terraform's going to say, great, I know what to do. I'm going to change all of these to be, app3 and owner of the dev that owns them. So I'm going to enter that, let Terraform modify it. I'm going to go back into my console, and now you'll see that, well, I'm going to do instance running, instance states, state running, instance state equals running. Cool. So you see that I have my 3 instances here, app1, app2, app3. If I click any one of them and I go to their tags, I'll see that, oh, this is Bob's instance, right? Owner equals Bob. Cool. This is a very interesting approach that people tend to use with count, and it works really well, like up to a point. But it falls down in one simple use case. So I have Alice, I have Bob, I have Charlie. And I've already told you that count, I'll show you real quick. Terraform state list. Terraform knows about these 3 different resources here, right? 0, 1, 2. I already told you that count operates on a LIFO model. So as new instances are created, they get added to the end. And as instances are destroyed, they get destroyed from the end. So essentially, that 0th instance that I have is going to stay alive until count goes to 0, right? Because it's the last one ever to be destroyed. Let's say in this case, I didn't, like, Bob and I weren't working out. Maybe Bob took another job, or he was performing poorly and got fired, whatever the case may be. Let's say I got rid of Bob here, right? And now we would expect our count to readjust, right? So I'm just going to go ahead and plan this for a sec. And we're going to look at this plan file a little bit more in depth. So if we go to the top here, it says, okay, great, you have these 3 instances. Terraform's going to say, I'm going to update this one and destroy this one. So notice what's happening here. Bob had instance with the index 1, right? And Charlie had instance with the index 2. When Bob got fired or whatever, left the company, and I removed them, notice how Bob's instance is now going to be modified into Charlie's instance. And Charlie's instance, which is at index 2, is going to be completely destroyed. So in this case, I went from count 3 to count 2, but since I removed that middle element, everything before that element, or sorry, everything after that element gets destroyed and possibly recreated depending on what you're using count for. So in this case, even though Charlie didn't do anything, he's kind of getting the crappy end of the stick here because his VM's getting destroyed and he's getting Bob's old VM here, right? So this is kind of a problem, and people shoot themselves in the foot with this all the time. So if I apply this, you'll see kind of the idea, and I just go back to the console and I refresh, you'll notice that Charlie's instance was destroyed and the instance that was Bob's has been modified now to be Charlie's. So we have a problem here. We've just gave Charlie like Bob's instance that he was working on and killed his own. How can we kind of get the same benefits of count with this more dynamic aspect, but the ability to not have this LIFO property whereby the last instances are always created on the end and then destroyed on the end? Well, that's where something like for each comes in, and I will, once it's finished destroying, I will get into that. Should be like another couple seconds. AWS is pretty fast with this. There you go. Cool. So real quick, I just want to comment out all of these developers and comment out this just to destroy everything, just to have a clean slate. Cool. So we're going to start from a clean slate to simulate this kind of same idea, the same workflow, but using for each instead of count. So I'm just going to give that a moment to destroy. And while it does, I'll go on my other terminal to start editing the configuration. So we've already seen count. We've seen that it is useful. It's very useful for scaling up quickly. But count really wants you to scale up with exactly the same resource, right? It's more of a cattle approach than a pet approach. If you all have more of like an SRE style background, or if you come from Kubernetes, it's more of like a deployment with a number of replicas, right? So I don't care which pods I have or which deployments I have. I just care that I have n number of them. That's what count is used for, right?